And we are going to go back to the oscilloscope, and hopefully we can stay here for the rest of the video as we try to wrap up this this basic tutorial and everything. And I'll try not to take too long on this, but there's really a lot to talk about here. So I'll try to sum it up as much as possible. All right, so I'm going to turn on the function generator now. I have my DC power supply powered on, so it is supplying positive and negative 12 volts to my circuit where it's needed. And I'm going to turn on my output signals. So you'll see the yellow. First of all, let's go over quick how you should be setting up these channels before I forget. Channel 1 should always be your first AC input. Okay, if I turn off my, I'm going to turn off the other channels here. Channel 1. This happens to be my my channel 1 output. Okay, you'll see that I have the amplitude set up already, which I'll show you how to set up amplitude measurement. But it says about 984 millivolts, which you'll have to trust me on this because I don't want to move the camera over right now. But my channel 1 output is set to 1 volt, so that makes sense, or 1 volt peak to peak. So that's roughly equivalent to that value in amplitude. Okay, so that's my channel 1 input. Now for channel 2 input, or channel 2 should correspond to your second input. If you don't have a second input, then channel 2 will be your output. But this is assuming right now that you have 2 channels. If you don't, then again, set your output measurement to the second channel, and for the third channel, you should have that be your output, assuming you have 2 channels. And then so on, if you happen to have 3 inputs, which would be getting pretty wild at that point, have your output be on your 4th channel. This isn't a hard and fast rule, but your professors will generally appreciate if you follow that convention as you take your classes here. Now, you'll notice that we can't really see all of the 3rd channel, and everything is kind of all over the place. I'll start by saying that these 3 values right here is the value at which it's hard to see the purple. I know. I'll try to represent it, or I'll try to demonstrate with the 1st and 2nd channels the most. But with the 1st channel and the 2nd channel here, you can see it's set to 200 millivolts and 2 volts. Let's see if make sure I get this right. Yep, that is the Y scale. Okay, the Y scale setting of the oscilloscope. Now they're very faint here, but you can kind of see them. There are dotted lines going horizontally across the oscilloscope, as well as vertical lines going vertically across. Each of these are divisions, and these values here tell you what each division means for each channel. Now you can have different divisions for your Y's, but you can't have different divisions for your X's. And the X division, that's because, well, everything would start to get all wonky if you start changing your time scaling and having everything set to its own time scale. So we can only alter the scale of the amplitude, or of the Y measurement, but for the X measurement time, those divisions are set by this value right here. You can control the time scale under horizontal, and then you turn the scale knob, and you'll see that changes the value. So it's going from 400 microseconds to 200 microseconds. If we zoom out, you can see more and more periods of time as the amount of time between each measurement decreases, all the way out to 1 second, and we can kind of start to see like a continuous measurement of whatever we're measuring as time goes on, right? But it's usually, it depends on what you want here. If you're trying to see, say you're doing a frequency sweep and you're trying to see how your system is affected over time, as it sweeps from, like, say at the start right here it was at 500 hertz, and now it's increased to 5,000 hertz, and you can see like how the amplitude changes. That's where this might be useful. But generally speaking, you want to try to keep the time scale to a point where you can pretty clearly see several periods of all of your channels. Now, and to set the the voltage scaling, the Y scaling of each channel, you can turn these knobs, and you'll see it. Well, that's the that's the yellow channel. You'll see it's going from 200 to 5 volts. Whoa, sorry, from 2 volts to 5 volts, 1 volt. Generally, you want to be able to clearly see you want most of the waveform to be in the picture. You don't want it to clip at the bottom or the top. If it's clipped off at the bottom of the top, because it's clipped because we know that there is the top of the waveform is way up here, but we can't see it in the picture of the oscilloscope. And if you don't have the picture of the oscilloscope, then it's not being measured. So your amplitude value is going to be off. I'll show you how to measure stuff in a second. Now we could fiddle with the vertical or with the amplitude scaling or the vertical scaling and the horizontal scaling until everything's perfectly in picture. And we can also mess with the offsets. The offset doesn't change any values, it's just moving the waveform up. So everything here is at 0. If I move this up to, what division is that? Let's see. That's up to where the 500 millivolt, the first 500 millivolt mark is. It's 500 millivolts because of this right here. We have it set to 500 millivolts. Then this is now 0 for that first waveform, and this is helpful so that we can separate everything and try to more clearly see the different waveforms instead of trying to decipher everything being all stacked up on top of each other. The easiest way for you to acquire your waveforms after you have everything set up and ready to go, assuming everything is working, is to hit this button right here that says Auto Set. It saves you from a bunch of time with having to change your scaling. Sometimes it won't auto set correctly because your waveforms look a little weird. In that case, you might want to fine tune things and mess with the vertical or horizontal or time scaling. Or if you want a different picture, you can adjust things yourself. But generally, it will set everything to where you want it to be for you to be able to clearly see things and get accurate measurements on your oscilloscope. All right, so I think next I'm just going to cover how to set up measurements and everything else. I'll let you figure out on your own. Because I could go on and talk about how to do FFTs on this, which are very helpful, but unless you really understand what FFTs are, then this is going to start to get really confusing. But anyway, just a quick recap of how we got here. I turned on all of my channels on my ECE function generator. I enabled them in here by pressing 1, 2, 3. I hit Auto Set to set them to a place where I can see them all without me having to do too much work. And finally, I'm going to start to take some measurements because that's what the purpose of this thing is. So, taking measurements is fairly easy. We hit the measure button up here, which is generally on the top of the oscilloscope. Hit measure, and you will start to see some options here on the bottom. These options on the bottom are pretty self-explanatory. You have add measurement, remove measurement. Don't worry about indicators and more. Let's go to add measurement, and this window will pop up. Let's try again. There we go. Now, in order for you to set up measurements, you need to select your source first. Your source is where you want the measurement to be taken from. Let's say we want our measurement to be taken from our output because we want to measure the output. Let's go to source and select 3, which is done by hitting this tab on top and then moving the knob to make the selection and then just hitting the tab button again. Sometimes it might double press accidentally. That happens a lot. Just keep trying to hit it maybe in a different way until the menu is gone. You should also just be able to go to the second menu, which is the second tab, which again, all these spots like this square here that says source, etc., measurement type, these all correspond to these squares, so just follow the squares. You can again turn, now instead of this top knob, for this second one, you want to move the second knob, or the bottom knob. And you could actually just move the knobs, believe it or not, to open up these menus, whichever you prefer really. And you have this whole list of measurements. Find the measurement you're looking for, you'll know which one you're looking for because that's the one you want to find. Or that's the reason why you went into this menu in the first place, was to take a measurement type. Let's say we're looking for amplitude. Amplitude's right here. We're going to hover over amplitude. So now we have amplitude and source 3, which is going to take the measurement from the output source on channel 3. I'm going to hit OK, add measurement. Again, it might double hit. In my case, it pressed this button twice, and now we have 2 measurements of amplitude up here. In case that happens, you can hit remove measurement. And these things are old, so you have to press it a couple times or press it in the right way, or else it won't work. And you select the measurement that you want to take. You can only have 4 measurements up here at a time, so keep that in mind. If you ever need to remove measurements, hit measure, again, remove measurement, and then select the one you want to remove. And there you go, it's gone. To get out of any kind of menu, just hit this button in the bottom right that says menu off. It'll exit out of whatever menu you're looking at, even the ones like the measurements on the bottom. Hit it again to have it turn back on if you wind up exiting out of everything. And now we're taking measurement of the amplitude on channel 3. All right. And that's basically how you wind up using the oscilloscope to take measurements. It probably is the most important thing that you should know how to do in this class, or in this major, for using this device. Just one more quick thing before we go, 2 more quick things. I'm going to talk quick about triggering, and I'm just going to talk about some of the other options on the channels. So with triggering, we can hit this button right here to start and stop the oscilloscope from running. Now, if I hit it right now, it's not going to do anything because the picture isn't moving, because we have the time scale set to such that it's not doing that. But let's say I zoom it out a lot and out to like I don't know, 200 milliseconds, and if I hit the run/stop button, let's change it here to 200 milliseconds, or let's do 400. If I hit stop or run/stop, it stops it. So it's no longer measuring anything. It has stopped the measure. It stopped the picture that we were looking at right there. If I hit run, then it'll start over again. If I hit single is the button right below it. It'll take a single snapshot until it fills up the screen, and then it stops. So it is no longer taking a measurement. This is useful for certain niche things. I'm sure you'll find use for it. For what the trigger is. As I was rewatching my recording of this section of the tutorial, I realized I did a pretty poor job of explaining what the trigger does. And all you need to know is that it helps set the level at which the oscilloscope needs to synchronize with the input channel that it's measuring to show one synchronized continuous waveform. There, you see how everything's kind of moving like this? The trigger is based off of one of the input channels to a certain level to try to get these from moving so that you can read them better. Okay, so this is the best, like, kind of most simple way I can put it based on how I know how this works. If the trigger isn't automatically set by auto set to somewhere where it should be, you can turn the knob until this starts to get in line with the waveform that you're looking at. In this case, where I have it set to input number 1, make sure that it's set to edge, type edge, and it's DC coupled. And everything else you shouldn't have to mess with. And again, just move this line, the trigger line, until it's at a point where everything is not moving. Let's reset my AC waveforms back to where they should be. Now let's see here, and then finally, now that we've kind of gone over pretty much everything that you need to know, let's talk about these channel options real quick and then wrap it up. You can select the individual channel options for each channel without turning them off by pressing these buttons when this menu is not up. And this menu I'm talking about, the one on the bottom here. So if I hit 1 again, this menu will pop up. This is a specific menu for channel 1. And on here is a couple things that you should take note of. First of all is the coupling. The coupling is essentially going to factor in DC or not into your waveform. And the way it does that is by applying a vertical offset based off of whether or not there's positive or negative DC. So let's say, for example, my output is, let's look at only channel 1 here. Let's say channel 1 is sitting right here, and then all of a sudden I accidentally, or for some reason, there's 1 volt of DC also being read wherever this probe is right here. That 1 volt is going to push this whole waveform up to right here. Alright, it's going to center it around this division here, which is we're at 500 millivolts for the vertical scaling. It's 500, 100 millivolts, which is 1 volt. And that's DC coupling. Essentially it helps you to tell if there's some unwanted DC component in your system. You can also use the oscilloscope to measure DC voltages in this way by allowing DC coupling, because if you are using, I'll do it right here. If you want to use your oscilloscope to check, I'll have to do it with the 3rd channel because my first one is plugged directly into my AC generator. If you want to use your oscilloscope to check for DC voltages and read DC voltages instead of having to use your multimeter, you can do that by looking at where this vertical line is. Right. So I'm going to set this back to 0 so that I can read these lines properly. Now I have DC coupling on for channel 3, and I'm going to read these divisions. Set to 5 right now. So 5, 10. And this is 15, so this is a little bit below halfway, so it looks like it must be around 12 volts DC is what's being read here, and I know that's correct because my DC supply is set to 12 volts. Okay, so that's what DC coupling is. If you turn on AC coupling, it will not consider any kind of DC measurement being read, right? So now if you say you have some kind of weird DC voltage that's really putting your waveform through the roof, and you can't you can't change the offset to get the signal to go back down to somewhere where you can read it better, you can turn on AC to eliminate that, and it'll bring it back down to 0 or to wherever you have your vertical offset set to for that channel. Next, we're not going to worry about termination. Invert. It inverts your signal. It flips it, which is pretty, I'm sure you can imagine what that's like, but I'll just show it right here. It's inverted right now. Oh, yeah, see, look. Invert is on, invert's off. It's also AC coupled, so it's right in the center. But it's not going to be, there's going to be no difference on this one, in this particular case between DC and AC coupling. Because there's no DC component in the output here. If you couple it to ground, surprise, it's going to read 0 because it is coupled together with ground. Ground is always 0, so it's going to read nothing. Bandwidth, don't worry about bandwidth too much. It may clean up your signal a little bit if you go to 20 megahertz because it's just going to be reading a little bit less frequency than the entire bandwidth of possible frequencies it can read. And on that note, that actually reminds me of one other trick you can know about here before we go, is if you hit this button underneath in the horizontal section, hit acquire, you're going to pull up a new menu, and this new menu lets you add some filtering options to your measurements here. You can choose any of these different types of acquisition modes. If you hit the bottom left button, which says this is the mode type, you can change it to peak detect, where it detects only the peaks of your waveform, which helps you kind of see the variance and the peak values for on your signal. High res cleans up the signal and helps filter out some noise. Average takes an average of everything up to a certain amount of points, depending on what you set. Oops, I just exited everything. Hit acquire again. Record length. It helps change the resolution of everything that you're measuring. It can be handy in cases where you want to look at absolutely everything. So just Or you can turn the resolution down if you're getting a bunch of noise in between each of your measurements on your oscilloscope to try to help you see roughly what your signal actually looks like if you're getting kind of corrupted by that. And everything else you shouldn't have to worry about too much unless you're getting really specific with certain things. And I think that just about covers it for this oscilloscope tutorial and the tutorial and everything else. So I hope that this has been helpful. Just remember good safe practices when you're working with everything on the bench. And feel free to do your own research on why things are, how things work, and as well feel free to look up the manuals for these different devices, because they all have one. And if you don't know how to do something or you have questions about something, may be able to answer them through looking at those manuals that are posted online by the creators of these things, or other YouTube tutorials or what have you.